Hey everybody, it's Mr. Troy here. I've got another video for you. In our pre-calculus series, we are in Unit 1, Polynomial Functions, and this video is on Lesson 2, Polynomial Division. Here we go. The essential question for this video is how do you divide two polynomial functions? Of course, in Algebra 1, you learned how to add polynomial functions and multiply polynomial functions and subtract polynomial functions. But in most instances, in Algebra 1, you don't learn how to divide them. In your Algebra 2 class, you likely learned some ways to divide them. Some people learn synthetic division, some people learn polynomial long division, and some people learn both. So those are our two methods that we commonly use to divide polynomial functions. Now, it's important we don't lose sight of what division means. So remember, if I am looking at dividing x cubed minus 2x squared minus 9 by x minus 3, I'm saying, what could I multiply x minus 3 by in order to make the x cubed minus 2x squared minus 9? Sometimes that's something we can just do intuitively. So let's take a look at that. The only way to get this leading x cubed would be if we were to multiply x times x squared. And similarly, the only way we would get this constant term of negative 9 is if we multiplied the negative 3 by a positive 3. So I'm wondering, is there something that we can put in the middle in order to figure out if this multiplies? Give it a thought. So if our middle term is 1x, then when we multiply, we get positive 1x squared and negative 3x squared, which is, of course, add to negative 2x squared. Similarly, we can see that negative 3 times x and x times positive 3 would cancel out, and that's why there are no linear x terms. Now, that whole process was not convoluted, but certainly maybe took longer than we would hope to. So these other processes, synthetic division and polynomial long division, are a way of doing that without having to go quite through that trouble. Let's see how they work. Now, of course, that transition was a bit of a fake out because before we can learn how to do something, we have to learn what and why. So let's start with the definition of a polynomial function. Hopefully this is a review to you or a reminder. It's the product of a constant and a variable raised to a non-negative integer power, or sums of those same things. So for example, if you said a constant times a variable raised to a non-negative integer power, you might say, okay, something like 3x squared. And I would say, sure, that works. Or how about 1.5x to the 17th? That would work as well. Since I'm allowed to add these things together, I could say 3x squared plus 1.5x to the 17th, and that would work. What I can't do is I cannot do things like this. 3x to the 1/2 doesn't count because that's not an integer. Or 1x to the negative third doesn't count because that is a negative integer. Okay? In Algebra 2, you likely learned about some parent functions. So for example, you would know this function right here as a quadratic, and the next one as a constant, because its y value never changes, it's constantly the same. And then this is not quite the parent function, but it's similar to the cubic. So this is a cubic function. This is the quadratic parent function, but it's kind of moved around a little. And then as we move higher, you can just say 4th degree. or you can learn all of the names if you want. You can call this a quartic polynomial. That's absolutely fine. If you look in a textbook, you'll see a slightly different definition. I'll put that here. So this is the definition that the textbook that we uses, and this just means some number times some power of x, and then some other number times the next power of x down, and so on and so forth until you get to a constant that has no power of x. This is certainly the one that you will use if you continue on in math, so good to know as always. Okay, so here's a side-by-side of the two ways that we divide polynomial functions. One is called long division, or polynomial long division, and one is called synthetic division. As you can see, synthetic division is a more stripped down process, but what you might notice as we're doing these problems, or as you look at these problems rather, is that these are actually the same problems. So we see the 2x cubed minus 7x squared plus 5, and we see those same coefficients here. We see an x minus 3 and a positive 3, and we see that these quotients and remainders are the same. So two different ways to approach the same type of problem. Okay, so the long division method can be used to divide any two polynomials, and most people will say that it must be used when the divisor has a degree that is, let's say, greater than or equal to 2. So if your divisor is a quadratic or a cubic, etc., you would use polynomial long division. Now, truth be told, there are ways to do this other than just using long division, but the single most straightforward way is to use long division. Okay, so let's make sure we know the parts. We have the divisor. Would you guess I can't spell that? We have the dividend. We have the quotient. And then we have a remainder. So those are the parts when we do long division. Now, long division is much easier if you remember how to do long division, the 5th or 6th grade method. So I would recommend to you, if you haven't done that type of long division in a while, take a quick break and see if you remember how to do long division. It really helps with what we're doing here. If you're going to do polynomial long division, you want to write out the entire problem, the dividend and the divisor, and you want to leave spaces for any powers that are missing. So for example, this x cubed minus 1, I'm going to make sure that I leave a space for the x squareds and the x's. So I'm going to write that out now. And then my divisor, of course, will go over here just as we're used to. And then the way that we're going to think about this is, how many times does x go into x cubed? Just think about the leading coefficients. Or in an even simpler way, what would I multiply x by to get x cubed? Well, my answer there is x squared. So I'm going to write that up top in my quotient. So that x squared I'm going to multiply through not by just the x, but also by the negative 3. I'm going to write them in their corresponding places underneath. And then just as I would do with long division, I'm going to subtract that. You do need to be careful. This 0 minus negative 3x squared is going to give you positive 3x squared. And we're going to pull down the rest of our terms. And now we say, what would I multiply x by to get 3x squared? Well, that would be positive 3x. Multiplying 3x by x minus 3, I would get 3x squared minus 9x. It goes through this process, so now I'm going to subtract all of this. Being careful, of course, to subtract the negative. So I get 9x minus 1. X goes into 9x 9 times. So I would get 9x minus 27. When I subtract that, I'm going to get a remainder of 26. Now, the way that you're going to write that remainder is normally plus the remainder over the divisor. Here's your quotient. And here is your remainder over your divisor, which is sometimes just called the remainder part, to be totally technical. On to the next problem. And before I even start, I need to write this into standard form. It's going to make my life much, much easier. So I'll pause and do that now. So I wrote out the dividend into standard form, and I made sure to keep my signs with me. So positive 2x to the fourth, positive 4x cubed, etc. Just making sure to keep those the same. And then I wrote the divisor out as well. Okay, so I want you to pause the video and I want you to try this one on your own, and then I'm going to write the work down. I'm just stopping part of the way through my work. Remember, the way you think about this is, what do I multiply x squared by to get 2x to the fourth? Well, that would be 2x squared. And then this comes from what happens when I multiply 2x squared all the way into the divisor. You'll notice here after this step, I'm just left with x squared plus 3x minus 2. So what do I multiply x squared by to get x squared? Well, just 1. So that's my next step. Okay, so I get to this point where I have x plus 1 as a remainder. So the answer to my division problem is 2x squared plus 1 plus, and then it's my remainder over my divisor. Now, you do need to be careful because this divisor factors. So you would want to make sure that the way that it factors wouldn't reduce away the numerator. Does that happen in this case? All right. Although that denominator factors, it factors to x plus 3 times x minus 1, and the x plus 1 in the numerator and the x minus 1 in the denominator, they don't cancel out. So that is our final answer. Here's another problem for those of you who just would like to try again, to give a try. I'm simply going to put the work up with no commentary so that you've got an example of some model work to look at. All right, here's our answer. And our remainder over our divisor, it doesn't reduce at all in this case. That's something we'll learn more about this unit and next unit as well. Okay, synthetic division is a shortcut that we can use when our divisor has a degree of 1. Now here's the big thing that you have to remember. If you're dividing by x minus 3, you want to use in your synthetic division positive 3. So you want to use whatever the 0 of your divisor is. So, for example, if you were using x plus 7 as your divisor, you would use negative 7 for your synthetic division. We will learn a little bit more as to the reason behind that when we learn about the factor theorem and the remainder theorem. Okay, so the process for this is really straightforward. For our divisor, we are going to use the 0 of that divisor. So in this case, negative 3, the opposite of that, positive 3. And for our dividend, we are going to write out just the coefficients remembering if we skip one. So for example, we need to use a 0 in this problem because we don't have any x cubes. So I wrote out all of my coefficients. They're in order, and I left a space for that x cubed that got skipped. So when we start, we just bring down this first term. And then for every step forward, we are going to multiply and then add. Now, what do I mean by multiply and add? Well, multiplying by this -3 that we've put out there. So 1 times -3 is -3. And then we're adding 0 and -3 to get -3. -3 times -3 is +9. And then we're adding to get -1. -1 times -3 is +3. And we're adding to get +1. And -3 times 1 is -3, and we're adding to get +1. Now, what does this all mean? Well, this number right here is your remainder. And then every other number represents a coefficient of your quotient. So +1, this is a -x, a -3x squared, and an x cubed. Now, you could check that by doing long division, but it does make sense that if you were going to divide x to the 4th by x, you would get x cubed something. All right, here's our final problem. So we're going to set up the coefficients, and we are going to use -1/2 as the number that we multiply by, or the number that we're plugging in, if you remember synthetic substitution from last year. Okay, so we're going to start by dropping this 4 here, and then multiplying each number down here through by -1/2. So -2. And then adding those, and we get 5. You can either write -5/2 or -2.5. That's up to you. That addition gives us 9/2 or 4.5, whichever way you like. And when I multiply that by -1/2, I'm going to get -9/4. And when we add here, we're going to get 35/4. So this is our remainder. Some people draw a little box here, so you know. And this is our quotient. So at first we would write our remainder as 35/4 over x plus 1/2. But this complex fraction is a little, I think the technical term for it is icky. So the way that we deal with that is we just multiply both the numerator and the denominator by 4. And we say 35 over 4x plus 2 is our remainder. Because we multiplied by 4 over 4, we know from our fraction rules that that is still true. Now, the reason that we multiplied that, but that we don't have to multiply the quotient, is because we were just simplifying this fraction here. So we don't actually need to go through and multiply by the quotient. Always go through and check to say, if I divided 4x cubed by x, would I get 4x squared? So our final answer is going to be 4x squared plus 5x plus 9/2, and then this remainder of 35 over 4x plus 2. All right, I hope that was helpful. Thank you for watching, and happy mathing.